हॅलो स्टुडंट, मी गायत्री सदाफळ पुन्हा एकदा तुमचं स्वागत करते आपल्या यूट्यूब चॅनलवर महाराष्ट्र व्हिडिओवर. तुम्ही अजूनही आमच्या चॅनलला सबस्क्राईब केलं नसेल तर चॅनलला सबस्क्राईब करा आणि साईडला दिलेल्या बेल आयकॉनला प्रेस करा. ओके, सो लेट स्टार्ट. आज आपण घेणार आहोत क्लास 10 सायन्स सोल्युशन्स पार्ट फर्स्ट, चॅप्टर नंबर हीट. सी द क्वेश्चन नंबर 4. फर्स्ट, फिलिंग द blanks and rewrite the sentences. In that A, the amount of water vapor in air is determined in terms of its dash dash. Answer, the amount of water vapor in air is determined in terms of its absolute humidity. Okay. B, if objects of equal masses are given equal heat, their final temperature will be different. This is due to the difference in their dash dash. If objects of equal masses are given equal heat, their final temperature will be different. This is due to the difference in their specific heat capacities. Okay. Third, filling the blanks. When a liquid is getting converted into solid, the latent heat is. Answer, when a liquid is getting converted into a solid, the latent heat is released. Question number 2. Observe the following graph considering the change in the volume of water as its temperature is raised from the 0 degree Celsius. Discuss the difference in the behavior of water and other substances. What is this behavior of water is called? Okay, see the diagram. Answer, if the temperature of water is raised from the 0 degree Celsius to 10 degree Celsius, its volume goes on decreasing in the range of 0 degree Celsius to 4 degree Celsius. It is a maximum at 4 degree Celsius. The volume of the water goes on increasing at the range of 4 degree Celsius to 10 degree Celsius. In general, when a substance is heated, its volume goes on increasing with temperature. Thus, in the range of 0 degree Celsius to 4 degree Celsius, behavior of water is different from other substances. It is called as anomalous behavior of water. Okay. See the question number 3. What is mean by specific heat capacity? Answer, how will you prove experimentally that different substances have different specific heat capacity? Answer, the amount of heat energy required to raise the temperature of a unit mass of an object by 1 degree Celsius is called as a specific heat capacity of that object. Question number 4. While deciding the unit for heat, which temperature intervals is chosen? Why? Answer, while deciding the unit for heat, the temperature interval chosen is 14.5 degree Celsius and 15.5 degree Celsius. For a reason, see the information given below in the following box. Okay, see this box. Question 5. Explain the following temperature versus time graph. Okay, temperature versus time graph. See, answer is, the graph shows what happens when a mixture of ice and water is heated continuously. The temperature of mixture remains constant till all the ice melts as shown by the line AB. This temperature is a melting point of ice. On further heating, the temperature rises steadily from 0 degree Celsius to 100 degree Celsius. As shown by the line BC, at 100 degree Celsius, water starts converting into steam. This temperature is a boiling temperature of water. Further heating does not change the temperature and the conversion water steam continues as shown by the line CD. Question number 6. Explain the following. That A, the role of anomalous behavior of water in preserving aquatic life in regions of the cold climate. Answer, in the cold regions during the winter, the temperature of the atmosphere falls below the 0 degree Celsius. As the temperature decreases, the water at the surfaces of the lakes and the ponds start contracting. Hence, its density increases and it sinks to the bottom. This process continues till the temperature of the water in lake falls 4 degrees Celsius. As the water at the surface of the cool further, that is, its temperature falls below the 4 degrees Celsius. It starts expanding instead of the contracting. Therefore, its density decreases and it remains at the surface. The temperature of the water at the surface continues to fall to 0 degree Celsius. Finally, the water at the surface is converted into ice, but the water below the layer of ice is at a 4 degree Celsius. Ice is a bad conductor of heat, hence the layer of the ice at the surfaces does not allow the transfer of heat from the water to the atmosphere. As the water below the layer of ice cream remains at 4 degrees Celsius. Fish and other aquatic animals and plants can survive in it. B. How can you relate the formation of water droplets on the outer surface of the bottle takeout of a refrigerator with the formation of DO? Answer. At the given temperature, there is a limit on how much water vapor the given water volume of air can hold. The lower the temperature, the lower is the capacity of the air to hold the water vapor. The temperature of bottle kept in a refrigerator is lower than the room temperature. Hence, when the bottle is taken out of the refrigerator, the temperature of the air surrounding the bottle is lower. Therefore, the capacity of the air to hold water vapor becomes less. Hence, the excess water vapor condensed to form a water droplets on the outer surface of bottle. Question C. In cold regions in winter, the rocks crack due to the anomalous expansion of water. Answer. Sometimes water enters into the crevices of the rocks. When the temperature of the atmosphere falls below the 4 degrees Celsius, water expands even when water freezes to form ice. There is an increase in its volume. As there is no room for the expansion, it exerts the tremendous pressure on the rocks, which crack and break up into small pieces. Question number 7. What is meant by the latent heat? How will the state of matter transfer into the latent heat is given off? Answer. When a solid is heated initially, its temperature increases. Here the heat absorbed by the body is used in increasing the kinetic energy of the particles of the body, as well as doing the work against the forces of attraction between them. As the heating is continued at a certain temperature, solid is converted into liquid. In this case, the temperature remains constant and heat absorbed is used for weakening the bonds and the conversion into liquid phase. This is called as a latent heat of fusion. When a liquid is converted into the gaseous phase at the boiling point, the heat absorbed is used for the breaking the bonds between the atoms and the molecules. This heat called as a latent heat of vaporization. Some solids under certain conditions are directly transferred into the gaseous phase. Here the heat is absorbed but the temperature remains constant. The absorbed heat is used for the breaking the bonds between the atom molecule. This heat is called as a latent heat of sublimation. In general, latent heat is the heat absorbed or given out by the substance during a change of state at a constant temperature. In transformations from the liquid to solid, gas to liquid and gas to solid, latent heat is given out by the body. Okay. Question number B. Which principle is used to measure the specific heat capacity of substance? Answer. The principle of the heat exchange is used to measure the specific heat capacity of substance. This principle is as follows. If the system of the two objects is isolated from the environment by keeping inside the heat resistance box, then no energy can leave the box or enter the box. In this situation, heat energy lost by the hot object is equal to the heat energy gained by the cold object. See the question number C. Explain the role of the latent heat in the change of the state of substance. Answer. When a solid is heated initially, its temperature increases. Here the heat absorbed by the body is used in increasing the kinetic energy of particles of the body, as well as for doing a work against the forces of attraction between them. As the heating is continued at a certain temperature, solid is converted into liquid. In this case, the temperature remains constant and heat absorbed is used for weakening the bonds and the conversion into the liquid phase. This heat is called as a latent heat of fusion. When a liquid is converted into the gaseous phase at the boiling point, the heat absorbed is used for the breaking the bonds between the atoms and molecules. This heat is called as the latent heat of vaporization. Some solids under certain conditions are directly transferred into the gaseous phase. Here the heat is absorbed but the temperature remains constant. The absorbed heat is used for the breaking the bonds between the atoms or molecules. This heat is called as the latent heat of sublimation. In general, latent heat is absorbed or gained out by the substances during a change state at a constant temperature. In transformation from liquid to liquid, gas to liquid, gas to solid, latent heat is given out by the body. See the question number D. What basis and how will you determine the whether air is saturated with vapor or not. Answer: whether the air is saturated with water vapor or not is determined on the basis of extent of water vapor present in the air. If the relative humidity is 100%, the air is saturated with water vapor. In that case, we can see the formation of water droplets on leaves and plant grass. If the relative humidity is less than 100%, the air is not saturated with the water vapor. Question number 8. Read the following paragraph and answer the following question. If the heat exchange between a hot and cold object, the temperature of the cold object goes on increasing due to the gain of energy, and the temperature of the object goes on decreasing due to the loss of energy. The change in temperature continues till the temperature of both the object attain the same value. In this process, the cold object gains the heat energy and hot object loses the heat energy. If the system of both the object is isolated from the environment by keeping it inside a heat resistance box, okay, then no energy can flow from the inside the box came into the box. First point, heat is transferred from the where to where. Second question, which principle do we learn about from this process? Third question, how will you state the principle briefly? Fourth question, which property of substance is measured using this principle? Okay, answer, heat is transferred from the hot object to the cold object. Second question's answer, this process shown the principle of heat exchange. Third question's answer, in this process the cold object gains the heat energy and the hot object loses energy. If a system of the two objects is isolated from the surrounding, heat energy lost by the hot object is equal to the heat energy gained by the cold object. And fourth point is, the principle is used to measure the specific heat of capacity of substance. Question number 9, solve the following. In that first problem, equal heat given to the object A and B of mass 1 gram. The temperature of A increases by 3 degrees Celsius and B is 5 degrees Celsius. Which object has a more specific heat and why, by what factor? Solution: data, mass is equal to 1 gram, it's a delta T1, it's a 3 degrees Celsius, and delta T2 is a 5 degrees Celsius. Q is same, here Q is the MC1, which is equal, delta T1 is equal to MC2, okay, and delta T2. We have given equation C1 upon C2 is equal to delta T2 upon delta T1, which is equal to 5 degrees Celsius upon 3 degrees Celsius. The ratio is 5 by 3. Thus C1 is greater than C2. The specific heat of A is more than the B, and specific heat of A divided by specific heat of B is equal to 5 by 3. Numerical B. Liquid ammonia is used in the ice factory for making the ice from water. If the water at 20 degrees Celsius is to be converted into 2 kilogram ice at 0 degrees Celsius, how many grams of ammonia is to be evaporated? Solution: data is equal to M1 is equal to 2 kg, delta T1 is equal to 20 degrees Celsius minus 0 degrees Celsius, which is equal to 20 degrees Celsius. C1 is equal to 1 kg calorie per kg degree Celsius. L1 is equal to ice, okay, ice is equal to 18 kilocalorie per kg. L2 is equal to 341 calorie per kg, and here is a conversion of that. We have to calculate M2. Here Q is the heat lost by the water, it's a M1 C1 delta T1 plus M1 L1. Just put out the values, we getting the 200 kilocalorie. Value of Q1, Q2 key, value of Q2 is the M2 L2, its the M2 value is we have to calculate 341 kilocalorie per kg is the L2 value. So we getting from there the value of the M2 easily, okay. Question number C. A thermally insulated pot has a 150 gram ice at a temperature 0 degrees Celsius. How much steam of the 100 degrees Celsius to be mixed to it so that water of temperature 50 degrees Celsius will be obtained? Latent heat of melting of ice is the 80 kilocalorie per gram. Latent heat of vaporization of water is the 540 calorie per gram. Specific heat of water is equal to 1 calorie per gram, okay. Data is equal to, we have value of the M1 here, delta T1, and from that we have calculated delta T1 50 degrees Celsius minus 0 degrees Celsius at 50 degrees Celsius. Value of the CW, L1 and L2 is given here, okay. Just put out the value and calculate the given answer, okay. Calculate the value of M2. Last numerical is the A calorimeter has a mass 100 gram and specific heat is 0.1 kilocalorie per kg degree Celsius. It contains 250 gram of liquid at 30 degree Celsius having specific heat of 0.4 kilocalorie per kg degree Celsius. If we drop a piece of ice of mass 10 gram or at 0 degree Celsius into a liquid, what will be the temperature of the mixture? Solution data: M1 is given as 100 gram, C1 is the 0.1 kilocalorie per kg degree Celsius, which is equal to 0.1 calorie per gram degree Celsius. T1 is equal to 30 degree Celsius, M2 is equal to 250 gram, C2 is equal to 0.4 kilocalorie per kg degree Celsius, which is equal to 0.4 calorie per g degree Celsius. Okay, T2 is the 30 degree Celsius, M3 is the 10 gram, T3 is the 0 degree Celsius, L is equal to 80 calorie per gram, C is equal to 1 calorie per gram degree Celsius. T is equal to how much? We have given Q1 heat loss by the calorimeter is the M1 C1 T minus T1. Q2 is equal to heat loss by the liquid is the M2 C2 T1 T minus T2. Q3 is the heat absorbed by the ice, it is the M3L. Q4 heat absorbed by the water form on melting of ice, M3C T minus 0 degree Celsius. According to the principle of heat exchange, Q1 plus Q2 is equal to Q3 plus Q4, M1 C1 T1 minus T. Just put out the value of the Q1, Q2 and Q3 and Q4 here. Arrange the equation, put out the values, and we getting the answer from that, that is a T is equal to 20.83 degree Celsius. Okay, this is the temperature of mixture. थँक्यू स्टुडंट. पुन्हा भेटूया आपण आपल्या नेक्स्ट व्हिडिओमध्ये. थँक्यू फॉर वॉचिंग.